Hello, welcome to Systems of Inequalities, Lesson 4.7, the Winter Break Edition. Thanks for watching. I know it's tough to watch when you've had 2 weeks off, but it's a good way to start the new semester and get off on the right foot. So now you're saying to yourself, what is a system? Well, a system is a set of two or more equations or inequalities with a common solution, that is an equation, or common solutions with inequalities. In the case of a system of equations, the solution is usually one point of intersection. In the case of inequalities, the solutions are any points in the commonly shaded space. Now that we know what a system of inequalities is, let's take a look at an example. The first example, I have a system of y is greater than 2x plus 2 and y is less than x plus 1. We're looking for the solutions that are common to both. Well, you can see to the right, I have both equations or both inequalities graphed. Just the line so far, but I have y is greater than 2x plus 2 in blue, and you can see how it goes through 2 and has a slope of 2. That one will be eventually shaded above because it's greater than. The red one is y is less than x plus 1 going through the intercept of 1 and having a slope of 1. That one will eventually be shaded below it, and then you can see that here in this next slide. Blue above, red below, and you can see this area right here, this pink area, that is where both lines are shading. And any of the points in that pink shaded area are solutions for either one of the inequalities, or for both the inequalities at the same time. Those are the only points. The blue points are solutions for the blue line. The red shaded area is solutions for the red line, or the second inequality. And the pink area, the area that's shaded for both, those are the solutions for the system, the solutions for both inequalities. Let's go ahead and run through a couple more. Here for example 2, we have a system y is less than 2x minus 1 and y is less than or equal to negative 3x plus 5. Notice the difference in the lines. Y is less than 2x minus 1, we get a dashed line, that's the blue one. Y is less than or equal to negative 3x plus 5 gets a solid line, that's the red one. And then you can see how they're shaded here. The y is less than negative 3x plus 5 is the red, shaded below. The y is less than 2x minus 1 is the blue, shaded below. And then you can see this area here, the pink area, is the common solutions. Any point in the pink area is a solution for both of the inequalities. So that is the solution to the system. Example 3, you have this system, y is greater than negative 4x plus 1, and then y is greater than 4x minus 5. Again, you can see the first one, negative 4x plus 1, is in blue, going through the y-intercept of 1 in the negative direction. The second one in red, also a dashed line, slope of 4 going through negative 5. And when we shade them, both are going to be shaded above the lines. As you can see here, the blue is shaded this direction. The red is shaded this direction. The common area is right there. So again, the solution to this system of inequalities is this pink area. Taking a look at example 4, we have two lines, and hopefully you notice right off the bat that these two lines are parallel. Y is less than negative 3x and y is greater than negative 3x plus 2. And this one's kind of a special situation. You notice that the y is less than negative 3x will be shaded below, and the greater than negative 3x plus 2 will be shaded above. So if we look at them when they're shaded, notice there is no area that's common. These are parallel. That means we can also tell that as these lines continue on, there's still not going to be an area where they intersect. So this one's special. This one actually has no solution. You can add, just like you can have two equations that have no solution, you can have two inequalities where there's actually no points that work for both. Finally, now that we've seen seen them worked out, let's try to kind of work one out together. We have this system, y is greater than 1/2 x minus 5 and y is less than negative 4x plus 3. Let's start with the first one, y is greater than 1/2 x minus 5. It's going to have a y-intercept of negative 5 go up 1 over 2. The line will look like this. If we graphed it, this is greater than, so we would actually shade everything above it. For the second line, we have y is less than negative 4x plus 3. Have a y-intercept of 3, slope of negative 4. Line will look like this. And for this one, we have it's shaded below. That means this area. So now you can see what it's going to look like, when you don't have a nice pretty graphic, but when you do it on paper. Here we can tell that the red one's shaded this way, the blue one's shaded this way. The solution is all of this area in here. So any of these points will be a solution to this system of inequalities. Okay, so now that we've tried a few of these and you've seen how they work and we've actually worked them out, take these last two on your own and try to graph them. It'll be good practice. You already know how to graph the lines. You already know how to shade. All we're doing is looking for that space that is shaded by both the inequalities. Okay, so graph them both, shade them both, find the area that is shaded by both the inequalities. And finally, our question of the day. You don't want to do it, but